Good day. Today we're going to discuss the types of statistical tests and how to solve them in PSPP. For this presentation, we're going to use PSPP, of course, to calculate for the data. And we're going to use Excel for encoding the data. And modern business statistics is used for the problems found in this presentation. As a review, these are the steps in hypothesis testing. Number 1, state the null hypothesis and the alternative hypothesis. Number 2, choose the level of significance. Number 3, select the appropriate test statistics and establish the critical region. Number 4, collect the data and compute the value of the test statistic from the sample data. And number 5, make your decision. For this presentation, we're going to discuss one-way analysis of variance, or ANOVA. So in an analysis of variance, this is when an Ftest is used to test a hypothesis concerning the means of 3 or more populations. The technique is called analysis of variance, commonly abbreviated as ANOVA. The one-way ANOVA is used to determine whether there are any statistically significant differences between the means of 3 or more independent unrelated groups. So 3 or more independent unrelated groups. So it's one step higher from your t-test, which for independent samples, which tests for significant differences between two groups. Okay. For example, you can use one-way ANOVA to determine whether the cholesterol level measured on a continuous scale differs based on the diet plan chosen by the respondents. So the dependent variable would be your cholesterol level, and the independent variable would be the method of diet plan chosen by the respondents, say plan A, plan B, or plan C, since there should be at least 3 unrelated groups. Again, note, t-test can be conducted using pairwise comparison. So to do pairwise comparison, you have to do A versus B, A versus C, and B versus C. So that's what you call your pairwise comparison. So it will be tedious if you have more than 3 groups. So that's why we use ANOVA to check if there is significant differences between the 3 groups. Okay. So with the Ftest, which is the one we used for ANOVA, it uses your F table. Okay. This is the F table. So you have degrees of freedom for the numerator, which is usually the first estimate, and you have the degrees of freedom for your denominator, which is your second estimate. So the first estimate is called the between group variance, and it involves finding the variances of the means between groups, or how many independent variables you have, or groups in your independent variables. The second estimate is the within group variance. Is made by computing the variance using all the data, and it's not affected by differences in the means. Usually it's the number of respondents, or the number of respondents per group. Okay. If there is no difference in means, the between group variance estimate will be approximately equal to within group variance estimate, and the Ftest value will be approximately equal to 1. So in bold are if your alpha or level of significance is 0.05, and below that if your level of significance is 0.01. So usually you find the degrees of freedom. So usually if there are 3, so the degrees of freedom would be 2, and let's say there are 10, so that would be 9. Okay, so the F value would be now 4.46, and we will reject the null hypothesis if your F value, computed F value, is greater than your this given critical value. Okay, if your computed value is greater than, so you reject the null hypothesis. Or if you're going to use the p-value, so we reject the null hypothesis if your alpha is less than 0.05. But if F value inyo gamiton, so then if you reject the null hypothesis is if the computed F value is greater than this given F critical value. Okay, so that's for the Ftest. So assumptions for your ANOVA. The dependent variable should be measured at the interval or ratio level, so it should be a continuous variable. So example, our cost is customer satisfaction, intelligence, weight. The independent variable should consist of 3 or more categorical independent groups. Example, relationship status, so whether you're single, married, divorced, widowed. Family economic status, either you belong to the upper class, the middle class, the lower class. And right now we have actually upper class, upper middle class, upper lower class, or middle class, that classification. There are 16 all in all. Then year levels, it's either you're a first year, second year, third year, fourth year. So that's categorical independent groups. Assumption 3, the population from which the samples, dependent variables were obtained must be normally or approximately normally distributed. So at least a total of 30 respondents. At least we are assuming that the population is normally distributed. Then the variance of the population must be equal. So Leven's test for homogeneity of variances is used. So equal variances must be assumed. So it should be greater than 0.05. If not, if your homogeneity of variances is less than 0.05, then we cannot use analysis of variance. So you must use Kruskal-Wallis test instead, okay, which we're going to discuss in the next video. Then, assumption 5, the samples must be independent of one another. So meaning if you have respondent in plan A, the same respondent cannot be also in plan B or in plan C. So you should be unrelated groups independent of one another. So in procedures in PSPP, so you encode your data for independent and dependent variables in PSPP. So you click on Analyze, Compare Means, One-Way ANOVA. Add your dependent variable as dependent variable and your independent variable as the groupings or groupings as factor, and then click descriptive and homogeneity, so we can also test for Leven's quality of variances. Okay. So example problem. 3 different methods for assembling a product were proposed by an industrial engineer. 30 employees were selected and randomly assigned to a method. The following data are the number of units assembled directly. At alpha equal to 0.05 or level of significance 0.05, is there significant differences between the methods? Because I have notes here. Leven's homogeneity 90 is P less than 0.05. Use Kruskal-Wallis H-test as mentioned earlier. And for T-test, post-hoc equal variances are assumed regardless of Leven's test. Okay? So especially if we conclude that there is significant difference between the methods, since we cannot know using ANOVA which of the variables are significantly different. So you use T-test for your post-hoc, and then you say we do your A versus B, A versus C, B versus C, which is actually quite tedious. That's not the problem. Okay. So usually the methods is presented in this manner. Okay. So this is down a number of items correctly assembled, and this is your respondents that used method A, respondents that used method B, and respondents that used method C. Okay. So to prepare this one for PSPP, you can have this one as your method and then the number of items that were correctly assembled. Okay. So you prepare this one in this manner. So in PSPP for variable view, we simply type in method and count or correctly assembled. Products. If you want to be as clear as possible. Okay. Then for value labels, we have 1, method A, and 2, method B, 3, method C. Okay. Decimal values. And this is nominal. And then this is numeric. And so our values are whole numbers. Then you can just simply have this one as true also. Okay. This is now your method. Then you can simply copy this one. So, treatment A, B, and C. So you can use, okay. So you use treatment. Okay. So, treatment. Dapat you should match your Excel file with your PSPP file. Data view, simply paste the values here. Okay, so this is now 1, 1, 1, 10 respondents. Then you have 2, 2 could be 10 respondents, and for 3, 10 respondents. So 30, all in all. Okay, so you have now your data. So you can now analyze, compare means, one-way ANOVA. Okay, and so for your factor, that's your the grouping method. And for dependent variable, so encode your dependent variable, which is your correctly assembled products. Then descriptives and homogeneity. Okay, then you click on post hoc. Okay. Usually you use Tukey or Sheffy or Fishers. Fishers or Tukey. This one. Okay. So this is now our results. So correctly assembled products. Our Levine statistic is 1.21, which is greater than 0.05. So meaning there is no significant differences between the variances of the three variables. Okay, so DF1 is 2 and our DF2 is 27. Okay, so the SIG is 3.15. So if you want to use the Ftest, that's 2 and 27. So 2 and 27. So that's 3.35 at 0.05 level of significance. Okay, our Ftest is 8.05. Okay, which is greater than your critical value here, greater than 3.35. So meaning we reject the null hypothesis. Okay, and if we check actually your ANOVA, the SIG is 0.002, which is less than 0.05. Okay, so there is significant difference. There is significant difference between the three variances. There is significant difference between the three variances. And to check which of your treatments have significant difference, you do your pairwise comparison, or in this case, it's a multiple comparison. Okay, so you either choose LSD or Tukey. Okay, so let's choose for LSD. So you simply look here. So this is treatment A versus treatment B. So it's 0.013. So meaning there is significant difference between treatment A and treatment B. Then for treatment A versus treatment C, there is also significant difference between treatment A and treatment C. Okay. Then for treatment B and treatment C, there is no significant difference between treatment B and treatment C. Okay, so that's 0.216 greater than 0.05. There is no significant difference between treatment B and treatment C. But there is significant difference between treatment A and C. So B and C, there is no significant difference. A and B, there is. A and C, there is significant differences. And if you look at 2 key, okay, you also actually get the same results. So for treatment A and treatment B, there is significant difference, and treatment A and treatment C, there is significant difference. But for treatment B and treatment C, there is no significant difference. Okay? And also, if you want, then also to check this one, you can always use also compare means independent samples t-test. So the grouping factor is your grouping variable, then assembly product is your test variable. Then you define groups. So for group value 1, let's say treatment A, and group value 2, let's say treatment B. Okay. Then options 95%. Okay. Then the result should be sig two-tailed, 0.990 equal variances assumed, so 0.013. So there is significant difference between A and B, treatment A and treatment B. And also to check, analyze, compare means, independent samples t-test. Then let's have defined groups. So instead of treatment A, let's have treatment C. Continue. Okay. And for the result, okay, this is sig two-tailed is 0.195, which is greater than 0.05. So there is no significant difference between treatment B and treatment C. Okay, so you have the same result if you do a post hoc using your independent sample t-test, or if you use post hoc using your multiple comparisons, either LSD or your 2-key. Okay, depending on what is being asked. So this is now your ANOVA. I think we forgot to analyze the problem first. Okay, so again, for ANOVA, since this is 3-way, so there is no, for HO, null hypothesis, there is no significant difference between the 3 means. And for HA, there is significant difference between the 3 means. So you can have that one as mu1, mu A is not equal to mu B, is not equal to mu C. Then for HO, that's mu A equal to mu B equal to mu C. Okay, then of course the level of significance is 0.05. Your level of significance is 0.05. The test statistic that we use is analysis of variance, or one-way ANOVA with post hoc. Select your post hoc. Then for appropriate, then the critical region is if you're going to use Ftest, so F value, computed F value should be greater than your critical value. So na siyang critical region. But if you're using to use p-value, so p-value should be less than 0.05. And collect the data and compute the values. You have already collected that one and you have made the decision. So there is significant differences between the 3 means, and there is no significant difference between treatment B and treatment C. But there is significant difference between treatment A and treatment B, and treatment A and treatment C. Okay, so that's for your analysis of variance.